Welcome back to another video on chemistry connections to water pollution and treatment. Today I'll be focusing on these three topics. The first topic is pollutants in water. The second topic is chemicals used for water cleaning. The third is chemical precipitation for water treatment. My first topic is pollutants in water. There are four types of pollutants in water. And what are they? Well, organic compounds is one. Some examples are phenolic compounds, petroleum, surfactants, pesticides, and pharmaceuticals. Some organic chemicals can cause leukemia, lymphoma, and harmful tumors. Inorganic compounds include salt, acids, and heavy metals. High concentration will cause severe health problems in humans and other organisms. Pathogens include bacteria, protozoa, or viruses. Human or animal waste are the major sources of pathogens in water. Microscopic pollutants are large visible objects in water, such as pieces of wood, metal, and plastic waste. The most common pollutant is trash, especially plastic. Due to the time limit, I will only discuss about the chemistry of organic compounds and heavy metals in polluted water. Chemistry of organic compounds in polluted water contain molecules mostly made out of carbon and hydrogen. Almost all of the bonds involved in organic compounds are covalent bonds, such as HH, HC. The disinfection of organic contaminants in water may produce toxic chemicals. Chemistry of petroleum as pollutants is a mixture of hydrocarbons with 5 to 40 carbon atoms per molecule, but it can also contain small percentages of oxygen, nitrogen, sulfur, and traces of metals. Some common chemical components include alkylanes and benzenes. Some chemistry of pesticides as pollutants have herbicides, insecticides, and nematicides. Herbicides account for about 80% of all pesticides. Herbicide consists of carbon, hydrogen, oxygen, and chlorine atoms, mostly with covalent bonds. The chemistry of heavy metals in polluted water is heavy metals, such as arsenic, are chemically dangerous for the human body. Arsenic binds with sulfur. How is arsenic harmful to the human body? Arsenic binds with sulfur groups in the human body and exerts its toxicity to sulfur containing enzymes. This critical enzyme effect causes problems such as the inhibition of the pyruvate oxidation pathway. Another mechanism involves substitution of arsenic for phosphorus in many biochemical reactions. It replaces the stable phosphorus anions in phosphate with the less stable anion. It leads to rapid hydrolysis of high-energy bonds in compounds to cause the loss of high-energy phosphate bonds and effectively uncouples mitochondrial respiration. My second topic is chemicals used for water cleaning. Various chemicals are commonly used for water treatment. Broad categories of these chemicals include disinfectants, oxidants, neutralizing agents, pH conditioners, coagulants, antifoams, aldehydes, flocculants, oxygen scavengers, scale inhibitors, and chlorination inhibitors. Ironically, more polluting risks also arise from the growing use of water treatment chemicals as more clean water is demanded by humans these days. I will focus on chemistry for two categories of these chemicals, which are disinfectants and oxygen scavengers. The chemistry of disinfectants for water treatment include disinfectants react with contaminants to remove harmful organic and inorganic components and also kill microorganisms such as norovirus. Some commonly used disinfectants include chlorine dioxide, ozone hypochlorite, hydrogen peroxide. A popular method is chlorination, which is to add chlorine or chlorine compounds such as sodium hypochlorite to water. Chlorine is a halogen and a strong oxidizing agent to cause the oxidation of organic molecules in water. Dissolved chlorine becomes an equilibrium, a mixture of chlorine, hypochlorous acid, and hydrochloric acid, which can kill parasites, bacteria, and viruses in water. What is oxygen scavengers and how are they related to chemistry? Oxygen scavengers can be organic or inorganic compounds. Inorganic oxygen scavengers add dissolved solids to the water and often are temperature dependent, such as sulfite. Organic oxygen scavengers include volatile products such as DHEA and carbohydrate. Oxygen scavenging is to prevent oxygen from producing oxidation reactions. Oxygen scavenger chemicals such as DEHA with the chemical formula and can react with ferric iron and steels to reduce it to ferrous iron to form a pacifist film of magnetite. My third topic is chemical precipitation for water treatment. And it is my introduction to chemical precipitation method. Chemical precipitation and water treatment is to transform dissolved materials in water into solid particles. Chemically, it is used to remove ionic constituents from water by the addition of counter ions to reduce dissolubility, thus allowing solid precipitate out water. Chemical precipitation has the advantages of low capital cost and simple operation. Major precipitation processes include water softening, heavy metal removal, and phosphate removal. Water softening primarily removes the chemical removal of calcium and magnesium from water. Heavy metal removal is to remove soluble salts of cadmium, chromium, nickel, and many others from water. Phosphate removal is important to protect receiving surface waters from plant growth stimulated by nutrient additions. So what is water softening? How is it related to chemistry? Well, hard water contains a lot of divalent calcium and magnesium cations, primarily as bicarbonates. The common method is to apply lime, which is calcium oxide, to precipitate calcium bicarbonate out of water. With lime in water solution, its pH is raised and the equilibrium of carbonate species in the water is changed. Dissolved carbon dioxide becomes bicarbonate and then carbonate. The process causes calcium carbonate to precipitate due to the exceeding solubility product. Magnesium can be precipitated as magnesium hydroxide. Finally, I'm going to explain the chemistry and chemical precipitation of heavy metals. Dissolved heavy metal ions can be chemically precipitated as hydroxide for removal by physical means such as sedimentation or filtration. The principle of the process is to use an alkali to raise the pH of the water in order to lower the solubility of metal ions for the precipitation. Sodium hydroxide can be used to react with heavy metal cations to form insoluble particles to precipitate. And my last topic for my video today is how chemistry and phosphate removal from water is related to my topic. Phosphate is an anion, and multivalent ions can be used to remove inorganic forms of phosphate, and calcium and aluminum are mostly used. Calcium is usually added to hydrated lime. When acids with Ca2 are reacting with the phosphate, calcium phosphate salts form following supersaturation in aqueous solutions. Dissolved aluminum ions are used to react with phosphate to form AIPO precipitates. Thank you so much for listening to my presentation, and I hope you learn more about the chemistry connections to water pollution treatment.